Hello, once again. It's been a long time. I know we've had fun learning this lesson. We're going to go through this and just do the best that we can. Really excited here. All right, I'm just going to go quickly through each question just so you can see it. Some of them I might do some multiple ways just so you can see multiple ways. Just know that there's more than one way to do it often, not always, but often. The first one, we have the square root of 8. The square root of 8 can be broken into the square root of 4 times the square root of 2. The square root of 4 is whole number 2, leaving us with 2 root 2. Got it. Here we need to focus on the root 90. The square root of 90 is the square root of 9 times the square root of 10. The square root of 9 is whole number 3. Don't forget there was a 4 in front of all of this. 4 times 3 is 12, and we have a root 10. Got it. Square root of 12 is the square root of 4 times the square root of 3. The square root of 4 is whole number 2, leaving us with a root 3. Got it. Down here, square root of 18 is where I want to focus. I'm going to do it on the side here. The square root of 18 is the square root of 9 times the square root of 2. The square root of 9 is whole number 3, leaving me with a root 2. But don't forget there was a 1/2 in front. So this is times 1/2, and if we're going to write it as a single simplified fraction, this is like saying 3 root 2 over 1 times 1/2, which is 3 root 2 over 2, if we finish the job there correctly. Got it. Root 98, this one might be kind of hard to do if you don't know what perfect squares go into it. Let's say you didn't know, but you were going to make just a tree. Root 98, 98 divided by 2 is 49. Stop right there. If you get a perfect square factor, then stop. So root 49 is whole number 7, and we have a root 2. Well, we want to write it in the correct order, 7 root 2. Nailed it. All right. If I'm looking at this, remember that this is the same as root 7 divided by root 5, and there's a 5 on top, right? That's 5 times this thing. So I like to think about it like this, as root 7 times root 5 as a fraction split up, and we're going to rationalize the denominator. I'm not going to show this work every time, but this is the process that we're doing. That gives us a root 35 on top and a whole number 5 on bottom. So we talked about it in the other video, but we need the bottom to be a whole number. So we do times root 5 to make that whole number 5. And if we multiply the bottom by root 5, we have to multiply the top by root 5, because what is root 5 divided by root 5? It's the number 1. So these have the same value. And then we have to reduce again. So it's reduce, rationalize, reduce, and you keep repeating that process till you can't simplify anything, you can't reduce anything, you can't rationalize anything. Well, this is just the square root of 35. The 5 cancels out. Got it. All right, this is the same as 3 root 80 over 8. I would focus on the root 80, though, by itself. We need to handle root 80. There's a few ways to do it, but if you know the biggest perfect square is the square root of 16, that would be root 16 times 5. That's 4 root 5. Let's do it another way just to see it. Let's say you didn't know 16, but you did know 4. Root 4 times root 20, you would not be done yet because you can simplify root 20 more. Root 20 is root 4 times root 5. And don't forget we have this root 4 as well. So root 4, and then root 20 would be root 4 times root 5. Well, what is root 4 times root 4? Whole number 4. Or let's just do it the longest way possible just to see it one more time. This would be root 2 times root 40, which is root 2 times root 20, which is root 2 times root 10, which is root 2 times root 5. So the square root of 80 is root 2, root 2, root 2, root 2, root 5. Well, root 2 times root 2 is whole number 2. Whole number 2. So we have 2 times root 5, which is 4 root 5. I don't know why I chose that one to show all the different ways, but there we go. Like, that's all the different ways that we've talked about. No matter how you do it, you get 4 root 5. So let's rewrite this. 3 times 4 root 5 over 8 would be 12 root 5 over 8. Well, then we have to reduce. 12 over 8 reduces to 3 over 2. So this is 3 root 5 over 2 when you finish the job. Yeah, super fun. Root 80 is 4 root 5. I don't care how you get there. You have to know how to get there. If it ends in a 25, a 50, or a 75, like, you know it's a multiple of 25, so that's good to know. So this would be the square root of 25 times 5. That's going to be your best way to do this. 5 root 5. That's kind of a common one. Might want to lock that one down. Ooh, if it ends in 2 zeros, you can always pull out a 100. So this would be square root of 100 times the square root of 3. Got it. And then if it's the same number, it's just going to be the whole, right? This is like root 5 squared, which is the same as root 25. These are all the same. But I told you guys in class, like, if you're thinking about this, you're going too slow. Root 5 is whole number 5. Root 2 is whole number 2. Root 10 is whole number 10. Root Mr. Balin times root Mr. Balin is Mr. Balin. The roots cancel out in that case. Root 32 times root 2. There's a few ways to do it. So if you do it the way we kind of did it in class, you would change this to root 2 times root 16, and then you still have this root 2. Well, root 16 becomes whole number 4. Root 2 times root 2 becomes whole number 2, which becomes 8. Or, hear me out, this is a rare time where I might go ahead and multiply them. That is the square root of 64, which is, again, 8. Root 32 times 2 is root 64. So not very often do we multiply first, but this is one time where maybe, just maybe, that's the easier way. Man, that almost never happens. Root 12, whole number 12. Not even going to talk about it no more. Root x, whole number x. You got that. 2 root 5 times 2 root 5. This is the same as 2 root 5 squared. This is the same as 2 times root 5 times root 5. This is the same as 2 squared times root 5 squared. All of these are the same thing. Which way am I thinking about it? I'm thinking about it like this. I'm looking at 2 times 2, I'm getting 4. I'm looking at root 5 times root 5, I'm getting 5. 4 times 5 is 20. Woo! All right. Rationalize the denominator. 3 over root 2 is 3 root 2 over 2. I hope we're picking up on that pattern. This is what the work looks like to rationalize the bottom. To get the bottom to be a whole number, we need to multiply it by root 2, which means we need to multiply the top by root 2 as well. We got to get good at that process, guys. The root 2 becomes a whole number 2 on bottom, and then you get a square root of 2 on top every time. This is the same as root 8 over root 49. Root 49 is just 7. Root 8 is root 4 times root 2. So the square root of 4 is whole number 2. We have a root 2, and we have a 7 on bottom. That's fun. Here, think real hard. What is that going to be? What is that going to be? We're going to have a root 6 join us on top and a whole number 6 on bottom. The 6's cancel out, and we're left with a root 6. Got it. All right. There's a couple ways you could handle this. It doesn't really matter that much, but if I can simplify the radical, I'm probably doing it first. It's typically easier to do it first. So what can we do here? We can do 60 divided by 3. Let me rewrite it. 60 over 3 root 8. 60 divided by 3 would be 20 over root 8. Break down the root 8. That's root 4 root 2. So that's 20 over 2 root 2. Well, 20 divided by 2 is 10. That's 10 over root 2. Ooh, take a minute. Breathe. 60 divided by 3 is 20. Root 8 is root 4 times root 2, which is 2 root 2. Root 4 is whole number 2. And then 20 divided by 2 is 10. But we still have to rationalize the denominator. That would be 10 root 2 over 2, right? We're doing times root 2 over root 2. So we rationalize the denominator by making it a whole number. And then one more division, 10 divided by 2, 5 root 2. I'm certain I didn't do it the fastest way. But that is the answer. Maybe someone out there can figure out a faster way. Who's faster than me? All right. Over here, this is as easy as these get. I'm not saying it's easy. It's not easy. I know it's not easy. Calm down. Didn't say it was easy. I said this is as easy as these get. Nothing reduces. There's a single irrational number on the bottom that we need to rationalize. It swings to the top, and when it swings to the top, it's done. There's nothing left to do. Nothing reduces, nothing simplifies anymore. So that is as easy as it gets. Dividing by root 3 and dividing by root 2, we will be doing a ton this year. Get ready. All right, this one looks like more work. Root 14 does not break down. That's 2 times 7, and those are not perfect squares. So we have 12 over 10 root 14. That would be 6 over 5 root 14 if I clean up 12 over 10 is 6 over 5. Rationalize the denominator. That'd be 6 root 14. Now hold up. What happens here? This becomes 5 times 14 on bottom, right? That's times root 14 on top and bottom. And you get 5 times whole number 14. That's 50 plus 20. That's 70. Then we have to reduce. Divide by 2 would be 3 root 14 over 35. You are not done until you have fully reduced and fully simplified. Type in the value that completes the triple. Please do this from memory. You got to know those 4. Determine which triple they come from. So if we know they come from a triple, we really just need 2 of the numbers to figure out the third one. But we're just looking for GCFs, guys. I'm going to go pretty fast through this. The GCF here is 2. Divided by 2, divided by 2, divided by 2. That's a 3, 4, 5. GCF here is 5. Divided by 5, divided by 5, divided by 5. That's a 3, 4, 5. I can divide all those numbers by 10. Divided by 10, divided by 10, divided by 10. There's another number, but I don't care. That's not a whole number. We need whole numbers. So times 2, which I guarantee the last one, times 2, 8, 15, 17. Sometimes you have to multiply. Remember we did that last chapter sum, right? Like if I had 5 divided by 2.5, we multiply by 2 on top and bottom to make them whole numbers. That's one way to do that. So if these were decimals, I did times 2 to figure out where they came from instead of the other way. What goes in all those? 3, divide by 3, divide by 3, and divide by 3. 7, 24, 25. Keep the ball rolling. Divide by 2, divide by 2, divide by 2. Divide by 3. Divide by 3, divide by 3. Here we go. Just 3 again. Divide by 3, 3, and 3. Like I said, I'm going fast. All I'm doing is looking for a common factor. We're trying to figure out which family these came from. Maybe a little harder. I can definitely divide by 4. Divide by 4, and divide by 4. Yes! 8, 15, 17. All right, moving along. Oh, really similar idea, but this time it says use triples to find x. So we're going to have to reduce the ones we have to figure out where it came from to figure out the missing value. All right, a lot of questions here, so we're going to go fast again. Sometimes it helps to list them. 18, 24. Divide by 6, divide by 6, divide by 6. So multiply by 6. Over here we have 60, x, and 65. Always list the hypotenuse last. What can I divide by? I can divide by 5 for sure. 5 times 12, 5 times 13. So this is a 5, 12, 13. So I divided by 5. So 5 times 5 would be 25. So we have 16, 30, and x. Divide by 2 is 8. Divide by 2 is 15. That's an 8, 15, 17. So multiply by 2, 34. Oh, 6, 8, 10 is so common, but let's just do it. 6, 8, and x. Divide by 2. Divide by 2. That's a 3, 4, 5. Multiply the 2 back in. Big numbers. We can go ahead and cancel out the zeros. So we have x, 16, and 34. Divide by 2. Divide by 2. That means the third one is 15. That's an 8, 15, 17. Multiplied by 2 would be 30. But we canceled out those zeros, so put them back in. 3,000. X, 96, 100. Definitely divide by 4, 25. Divide by 4, 24. 7, 24, 25. Nice. So multiply the 4 back in, 28. Got it. Can't zoom out. Woo, I'm getting old, guys. 15, 36, and x. Can definitely divide by 3. That would give me 5. Divide by 3 would give me 12. And that's a 5, 12, 13. So multiply the 3 back in. And that's going to be 39. 9, 12, 15. That's another really common one. But let's just run it through. Divide by 3. Divide by 3. That's a 3, 4, 5. Multiply the 3 back in. Where to zoom in, my friends? Oh, they're done. Guys, I loved them. We'll miss them. All right, moving along. A little tougher to simplify than the first few pages. Reduce, rationalize, simplify, keep reducing, keep rationalizing, keep simplifying, keep having a good old time. So we have 4 root 35 over 6 root 42. Reduce whole number with whole number, 2 and 3. Reduce radicand with radicand. 7 times 5 and 7 times 6. Now it's a little bit easier. So we reduced, then we rationalize. Multiply the radical to the top. We have root 30. And this would be whole number 6 times 3 would be 18. And then if we can reduce, if we can simplify the radical, we do. If we can reduce, we do. Well, 2 over 18 is 1 over 9. 2 over 18 is 1 over 9. And what is 1 times root 30? It is just root 30. All right, take a look here. Got some fun stuff going on. That's multiplication. So we have 1/2 times 8. Let's put that there. Root 18 and root 12. Root 18 is root 6 root 3. Root 12 is root 6 root 2. Why did I do that? Because this becomes 1/2 times 8. That's still there. What is root 6 times root 6? Whole number 6. And then we have root 3 times root 3, which goes back to root 6. So we pull out the common factor 6. Root 6 times root 6 is whole number 6. Root 3 times root 2 goes back to 6. Are there any numbers that are perfect squares that go into 6? Nope. So that part's done. Here, we got to multiply 1/2 times 8 times 3. The order doesn't matter. Half of 8 is 4. Sorry, 1/2 times 8 times 6. Half of 8 is 4 times 6 is 24. 24 root 6. All right, there's got to be more, please. Okay, perfect. Oh, yeah, right, acute obtuse. Remember, I told you that if they're all whole numbers, you have to verify if they're a triangle or not. If they are not all whole numbers, like if one of them's like 5 root 2, for instance, not a whole number, I told you don't have to worry about verifying it. You can just move forward assuming it's a triangle for my class. That's not true for always, but that's all we're doing for right now. All right, so there's not a lot of room to work here. Sorry about that. I need to organize this stuff better. At least this first section's cramped. So is it a triangle? 4 plus 5 is more than 5. Yes. Once we establish it's a triangle, we're going to square each number. 16, 25, and 25. We add the two smallest ones. 16 plus 25 is 41. So 41's bigger. If c squared is smaller, if the standalone number is smaller, it's acute. That's in the lesson that we did. If c squared is smaller, that means 90 degrees got smaller. If c squared is bigger, that means 90 degrees got bigger. And since c squared is smaller, 90 degrees got smaller, that means the triangle only has acute angles. Is it a triangle? 2 plus 10 is 12. It's more than 11. Yes, we're good. So then we square these numbers. 4, 100, and 121. We add the two smallest ones. 100 plus 4 is 104 versus 121. Oh, c squared is bigger. That means 90 degrees got bigger. That means it's obtuse. Oh, we know 3, 4, 5. That's a right triangle. Moving on. We square the numbers. This would be 49. That would be 17 over 2. So that would be 289 over 4 and 25. I wouldn't make you do that without a calculator. Dang. Well, we know that 49 plus 25, those are going to be the two smallest ones, right? 7 and 5 are the small sides. So 40, 60 plus 14 be 74, and 289 over 4. That might be kind of hard to do. I don't know. Yeah, I would definitely not make you do that without a calculator. But since it's here, let's do it. That would be, let's see, 200 divided by 4, 80 divided by 4, 8 divided by 4, and 1 divided by 4. So that would be 50 plus 20 plus 2 plus 0.25. 50, 72.25. So 74 and 72.25. C squared is smaller. Yeah, that's harder than intended. Sorry, friends. That's not what we're doing right now. I need to go back and maybe remake this, or at least change that question. I'm not going to, but I probably should. 8, 15, 17, that's a right triangle. We've learned that. 8 plus 4 is 12. Is 12 more than 9? Yes. So then we go to Square Town. Square, square, square. 64, 16, 81. We add the two smaller ones. 80, 81. 81 is bigger. If c squared is bigger, it is obtuse. Nailed it. Not a triangle. 2 plus 5 is 7, and 7 is less than 8. Remember, to be a triangle, A plus B has to be greater than C. That is pre-square. That's before you square it. We did that 2 chapters ago. We did not square things 2 chapters ago. This is pre-square. In order to be a triangle, 2 plus 5 would not reach. 7 is not enough room to reach. Don't tell me it's some kind of triangle when it's not even a triangle, my friends. That's our last one. I'm really going to miss this assignment. This was a fun one. I really like this stuff. Hopefully you guys have a good day. Hopefully you learned something. Hopefully you got most of this right on your own. I know that we work really hard. I appreciate each and one of you. Love you all. Have a great night.